Here you go. Let's review some of the stuff from last class. You will need your calculators to do this stuff, and I'm hoping some of you guys did do this stuff. Let's find out what the equations will be for g of t and for h of x, given just these points. All right? First of all, y equals, what's our initial value? And I shouldn't even put y, I should put g of t, because this is what they're asking for. Our initial value is always what's across from 0. It's 100, right? It's an exponential, so I'm raising to the x. Does anyone know what goes in? 1.1. And we can either put this in a stat edit in the calculator and figure it out in stat calc, or you should realize, well, to get from here to here, you multiply by 1.1. To get from here, you multiply by 1.1, and so forth. So that's our actual growth factor right here. That's our b value. And here's our a, whatever is across from 0, and here's our b. And we just slap an x on there because they're exponentials. That is obviously growing because it goes from 100 to 110 to 121, so it's increasing. So that makes sense that this is bigger than 1. It's bigger than 100%. Now the next one, it is a decrease. So h of x equals, what's my initial value? 100. It's still 100. So whatever's across from the 0, that's my a value. Still 100. Now, and here should be less than 1, because someone said it's decreasing. All right? We put our x here. Anyone know what goes in there or no? I'll get it. I'll get it for you. If I go from 100 to 95, how much percent? If this was 100%, it went to 95%. How much did we lose? 5%. So guess what? It would be 100%. 100, which is 1 minus 0.05, right? So let's go 0.95. Which means approximately, you multiply this times 0.5 you get here. But now, if you do this in the calculator, I think it's like 0.9478 something. But if we round it to decimal places, that would be 0.95. Simple. Okay? Use the calculator. Whenever they give you data like this, just use the calculator. Stat edit, measure it in. And if you hit stat calc, you go to exponential regression. All right? How about some of these? All right, now they just want the function. You guys should be able to do this. What's f of x? What is it going to start with? 12. Our initial value goes a, b to the x, right? A is our initial value, and they say it's 12, so let's start with 12. We know it's going to be to the x. What goes into parentheses? Close. 1.4. Bam. This is, in here, either 1 plus our rate or 1 minus our rate, whether it's increasing or decreasing. This says it's increasing, so we're going to use this, which means it's 1 plus, well, 8% in decimal, 0.08, right? 0.08. So I could have technically put this in parentheses here. Why don't I just add them? I just put it in there like that. That increases at 8%. And its initial value is 12. Good. Good. Let's find d of x. No, man, if I had money, I'd love to triple every year. Hey, what is the initial value? 10. So that goes here. Now, we know it's the x. What goes in the parentheses? 3. If I'm tripling it every year, do I multiply by 3? There you go. Here's my a. Triples, that's my b value, that's my factor. That means it's being multiplied by 3. And guess what? That's my b value is. Right? Cool. Last one here before we kind of go on to the next topic. They give us p of t. Here's our equation right here. What is the initial value? 1.23. That's my initial value right there. Close. What's my rate?
Oh no, 4.9.
The rate is 4.9%. How do we get that? Because here it's 1 plus my rate, correct? And If I get 1.049, that means I have to add 0.049 to 1 to get this, don't I? I mean, I can subtract 1 from both sides to get 0.049, do it algebraically. But I want the percent. I slide that 2 to the right. That is 4.9%. So, is it increasing or decreasing? Increasing. Increasing because it's bigger than 1. You're adding to 1. And it's increasing. Good, good, good. Logarithmic function. Lovingly called logs. These are not as bad as you think. You just need to understand one simple rule when it comes to logs. Okay? If I have an equation, y equals log base b to the x. Alright? That is the same thing as saying b raised to the power of y equals x. Now, when you look at that, you're like, oh, I got to memorize that. That's tricky. It's confusing. Let me show it to you another way. Okay? I'm going to write my log first. If I have log base b to the x equal to y. I had a student several years back named Mahogany. Some of you guys might remember this from algebra 2. Mahogany theorem. And she came up with a very simple way and did really good on this unit. She said, well, in order to just lose the log, all I've got to do is switch this and this. And I lose a log. So now b has y as an exponent, because doesn't that look like the x is the exponent here? And it equals x. Oh my goodness, look at that. Just switch those two. They can drop the log. Alright? So if we just switch those, there you go. Mahogany came up with it. Great. Mahogany here. Okay, hold on. So, you see these next 4 problems? All I want you to do is rewrite them. You're not solving, just rewrite them without the log. I'll give you about a minute. Alright, so what is this first one here going to be? 2 cubed equals 8. That's right, because all we do is switch these two, and then we can drop the log. And 2 cubed is 8, right? So that would make sense that log base 2 of 8 would give you a 3. In your calculator, you know there's a log button? So I say log, and I want to put 8. But, geez, how can I put the base there? In between the log and the number 8? Anybody remember? See, this one would give you 3. That's not right. Yeah, if I had alpha y equals, that gives me a fraction, right? But if I had alpha window, look what choice 5 is. Bam! Log base 2 of 8, and we set of 8, and it should be 3, right? And it is. It's 3. Because 2 cubed is 8. You see how it works? Nice. So, what's the next one? 3 to the 1/2 equals radical 3. You just switch these two and drop. And that should make sense because anything to the 1/2 power is a square root, right? So that's like saying radical 3 is 3 to the 1/2. That's right. Okay. What about the next one? Absolutely. Because let's not forget our rule of negative exponents. What do we do to make negative exponents positive? We flip it. So that's 1 over 5 squared, which is 1 over 25. Absolutely. And if I want to get crazy, check the calculator. Now that I know how to do log base 5 of, and I'll use this, 1 over 25, right? That should give us a negative 2, shouldn't it? I mean, this stuff. And what's the last one? What's the last one rewritten?
It's 4, 0.
Anything to the 0 power is 1. Anything. Anything. There you go. You now know how to change a log into a statement without log. Right? Well, now that we know how to get rid of the log if we're given just 1, okay? Let's take a look at some properties of logarithms, okay? We did this last year for Algebra 2, Trey. And this is a little bit review. I know you probably didn't have it memorized, so as we start doing these things, maybe they'll come back. Right? The product rule. If I'm taking the log of any thing of any two things that are multiplied. Right? It's the log of 20. Is it the log of 2 times 10? The same thing as the log of 5 times 4. What about the log of 3x? Well, that's 3 times x. That can be rewritten as the log of r plus the log of s. So if I'm multiplying r times s, okay, I'm taking the log of a product. I can split that up into the log, two separate logs of the sum of those two values. And multiplication, you'll notice, as in many things, turns to addition, right? You see that? That goes vice versa. If I'm given this, and I want to make it into a smaller expression, I can change it back into this whole thing right here. So it works both ways. So, a question. If multiplication turns to addition, what do you think division is going to go into? Absolutely. Into subtraction. So if I'm actually subtracting some value r divided by some value s, okay, I'm taking a log of that, that's like splitting it up and saying the log of r minus s. Be careful, order matters with division and subtraction, doesn't it? Order doesn't matter with multiplication and addition. With division and subtraction, it does. So you want to make sure it's the numerator first, subtract the denominator. All right? Keep in mind, if I was to read this right here, like a subtraction problem, doesn't this middle line look like a minus sign? So it'll be r minus s. Of course, I think we're big enough to know that that means division. So to help us remember that it's subtraction for logs, r minus s right there. Log of r minus log of s. And again, it works both ways. If I have a subtraction problem on the right, I can truncate, I can make it into a small expression. It's the log of the division. You did? This is the most important one when it comes to solving for variables. Because aren't we doing exponential equations? Exponential equations and regressions have what as the exponent? When we're writing an exponential regression, and we come up with the first, like when we did the review from yesterday, what was always the exponent? The x. Well, if I got to solve for that, it's easier to solve for x if it's a coefficient like in front instead of an exponent, isn't it? It's a lot easier. This power rule helps us do that. Okay? That's to say, if I'm taking the log of something that has an exponent, like r to the c, this c comes down and becomes the lead coefficient. Okay? So now I can solve for that variable c, and it's going to be a million times easier. And again, that works both ways. Okay? Now, in the calculator, I just showed you, if I hit the log button, there was no base, right? Let's do log base. So if there's no base, if I just have log of 10 here, what is the base that's not written? No, big guesses. E. But no, that would be pretty crazy. But here you go, ready? If I have x, it's assumed that, well, the coefficient is 1 even though I don't write it. The exponent is 1 even though I don't write it. For logs, the base is assumed to be 10. It's always base 10 if it's not written. Now, if my coefficient for x was a 2, I can't leave it blank. I have to write the 2. If my exponent was cubed, I can't leave it blank. It has to be cubed. So if my log base is anything besides 10, I have to write it. If it's 10, I don't have to write it. Okay? Because with exponents, everything by 10s, that's how you slide the decimals, and you do numbers by places. Yeah, absolutely. Absolutely. So, the same rules apply to natural log. You know the calculator, there's a log button and there's a natural log button? There's a natural log button? Well, what's the big deal between log and natural log? There is one huge difference. We all know our friends at the number e. If I have this, e to the x, if I take the natural log of it, guess what happens? These cancel and it just becomes x. Because, and this is what you want to write down, the natural log of e equals 1. Okay? And similarly, if we have and e to the exponent ln, that also equals 1. So, how does that help me? If I have e to the x equals 2.718. Well, the number e is 2.718. It's like pi, it goes on forever. So it is approximately 10. So this x should really be a 1. Yes. Yes, that's why we use natural log instead of log. So whenever there's an e involved, you want to use natural log. That's what you want to write down if you don't know that. If I take the natural log of both sides, these cancel. I now have an x equal to the natural log of 2.718, which is e, whatever. If you put this in your calculator, it'll be really, really close to 1. It won't be 1 because I chopped off all those other decimals. But that's what it'll be. Some people, when they're solving for things, they use natural log for everything. That way you don't have to worry if it's e or not. Use natural log. You can do that. When it calls for you to use log to bring the exponent down, you can use natural log, because natural log, the same rules apply. Natural log, this will come down to be x times this. And because this is 1, x times 1, and x. Same rules apply. Okay? All right, let's take a look at this. You guys are going to kind of work with me on this. Tell me what you think. Some of these are true, some of these are false. Number 1. Now, keep in mind that the same rules use for log or for natural log. Is number 1 true? If I take the natural log of x plus 2, is it the same thing as saying the natural log of x plus the natural log of t? I hear a yeah and I hear a no. Look at your rules.
No, it's false.
It is no. This is false. How come this is false? Yeah, they're both. I can't distribute a natural log. That's not right. Okay, I can't do that. What would this side have to be to make it true? It would have to be the ln of what?
X.
Yeah, x times 2, or 2x. X times 2, right? Multiplication turns to addition. Okay, what about 2?
No. It's false.
You tell me.
No, it's false. That's not the original.
Good catch. You're right. Good thing you changed your position. This is false. How come? Because in order to get this 7 would have had to come up as an exponent, wouldn't it?
Yeah.
Not this. This turns into log 3 of 7 plus log base 3 of x. That's a multiplication rule. The one on the right is the exponent rule. So that is definitely false. Okay. Number 3. What do you guys think?
True.
It is true. It is multiplication, and it definitely turns into addition. Log of 5 plus log of x. Same base.
True.
Number 4?
True.
True, of course, because the same rules for logs apply to natural logs. All right, division means subtraction. And this is the numerator, the x. And 5 is the denominator. Good. 5.
False.
False. You can't just distribute the log on top and the bottom. You can't do that. That is a false. Absolutely false. What would this be? Yeah, what would have to be on the right side to make it true?
Log x. X minus 4. Log.
You got it. Log x minus log 4. And because that's base 10 and we know it because there's no number there, we don't have to write our base 10 here. We just know. 6. True or false? True. True. This is the big one we're going to use a lot. 3 should come down as a coefficient, and it does. 7. What do you think? It's written differently, but is it true? You're saying false. Think about it. What should... You got it? Okay. What should this be? If this is an exponent, what should it be? No, this whole expression, how would I rewrite it? 2 log 5 of x, right? So really, you're just doubling.
Oh.
See, so doubling does not mean multiplying by itself. False. Now, you would double it. Maybe, you know what's tricky? If I double something, isn't it like adding it to itself? Like 2 times 10 is 20, it's 10 plus 10. I probably could have put a plus here. And that would have made it true. It would have been equal, but it's not a rule, but they would have been equal. Okay? So that's tricky. Be careful. What's one thing I could have done to the left side if I added something to make it true to the right side? Anyone know? If I were to just put this in parentheses here, I take this value and I square it. That's the same as this. Taking this value and multiplying it by itself. Yeah. See, so they really throw you a curveball there. That would make you think. You guys did good. You guys did good. So this is false. How many true, how many false do we have? We had, 4 false, 3 true. Good.